Hello, and welcome to SolidCAM Professor. This video is an introduction into SolidCAM Milling, showing just how easy it is to program with SolidCAM, simulate toolpath, and generate G-code. Before we begin, I'd like to introduce you to our automatic CAM part definition settings. In the SolidWorks menu, I'll click on SolidCAM, SolidCAM Settings. Under Automatic CAM part definition in the list, note there are four important sections: definition of CNC controller, definition of coordinate system, definition of stock, and definition of target. By default, these settings are enabled and can be especially helpful for a 30-day trial test drive user. Keeping them enabled will automate the CAM part definition process so we can immediately begin evaluating the software. I'll click OK to close the dialog. Now, here we have this simple cover ready to go into SolidCAM for programming. I'll go to the SolidCAM drop-down menu at the top of the screen, SolidCAM, New, and select Milling. I'll be prompted to save this new milling part. I'll save it in the Model File Directory location and select OK. The CAM part is automatically defined, and I can start adding operations by clicking OK. In the SolidWorks graphics area, we see our coordinate system has been automatically defined and exists on the top left corner of our model box. The stock is represented graphically by the gray bounding box around the model, which was then selected for our target geometry. Next, we move to the SolidCAM Manager on the left, where I can add the first operation. I'll right-click Operations, add Milling Operation, and select Profile. When the Profile Operation dialog appears, I'll click on the New button to define our geometry. In the SolidWorks graphics area, I'll select an edge around the outside of the model. Then, using the Geometry Edit dialog on the left, I'll select Auto Constant Z and click Yes to accept the selection. Auto Constant Z will close the chain by automatically selecting all connecting entities on the same Z level. Our toolpath will work around this geometry. I'll click the green check mark at the top left to accept and display the operation dialog. Next, we'll define a tool by clicking on the tool branch. I'll click Select to bring up the tool table. I'll click on the Add Milling Tool button on the bottom left of the dialog and choose End Mill from the list. Under the Topology tab, I can define the physical dimensions of the tool. For this example, we'll use the default values, which provide us with a 6 mm diameter tool. I'll click Select to exit the tool table. Next on the tree are levels, where we'll define the milling levels. I'll click on Upper Level and simply select the top face of the model in the SolidWorks graphics area, then click OK to accept. Next, I'll click on Profile Depth, select the bottom edge of the model, and click OK to accept the selection. Notice that the milling levels fields have changed to red. This is because the values are associative to the picked entities, and if the model changes, these associative values will also change. In the Technology branch, we'll use the default settings. The tool will mill on the left side of our geometry at a constant depth, and with no wall or floor offsets. Lastly, we'll move on to the Link branch. Under Lead In, I'll choose Arc and set the radius value to 4. Then, under Lead Out, I'll select Same as Lead In so the tool enters and exits the cut in the same fashion. Now I'll click Save and Calculate to add this profile operation to the CAM tree and calculate the toolpath. Next, I'll select Simulate to display our simulation control panel. We'll use our default host CAD mode to present the wireframe toolpath by pressing the play button. Finally, I'll close the simulation and profile operation dialogs by selecting Exit for both. Next, let's move on to milling this pocket. From the SolidCAM Manager, I'll right-click Operations, add Milling Operation, and select Pocket. When the Pocket Operation dialog appears, I'll click the New button to define our geometry. In the SolidWorks graphics area, I'll pick a single edge of the pocket and select Auto Constant Z on the left to close the chain, and I'll click Yes to accept the selection. Our toolpath will work inside this geometry. I'll click OK to accept and display the operation dialog. Next, we'll need to select a tool by clicking on the Tool branch. I'll click Select to bring up the tool table. For this operation, we'll use the already created tool from the previous operation by selecting it from the list. I'll click Select to exit the tool table, where we can move on to the Levels branch. I'll click on Upper Level, and again select the top face of the model in the SOLIDWORKS graphics area, then click OK to accept. Next, I'll select Pocket Depth, and pick the lower face of the pocket, then click OK to accept the selection. In the Technology branch, we'll use the default settings. Our toolpath will use a contour strategy and will overlap 50% of the tool diameter with each step over. The offsets are set to 0. Lastly, we'll move on to the Link branch. In the Ramping area, I will select Helical Entry from the drop-down menu. Now I'll click Save and Calculate to add this pocket operation to the CAM tree and calculate the toolpath. Then, I'll select Simulate to display the wireframe toolpath by pressing the play button. Finally, I'll close the simulation and pocket operation dialogues by selecting Exit for both. The last operation we'll add is drilling. From the SolidCAM Manager, I'll right-click Operations, Add Milling Operation, and select Drilling. The drilling operation dialog appears, and I'll click the New button to define our geometry. Under Select Centers By in the Drill Geometry Selection dialog on the left, I'll use the default multi-positions and simply click on the top face of our model in the SolidWorks graphics area. For this selection, multi-positions automatically picks the centers of all circle entities on the top face. I'll click OK to accept the selection. Next, we'll define our tool. I'll click on the Tool branch, then the Select button to bring up the tool table. I'll select the Add Milling Tool button and choose Drill under the Drilling Tools list. The diameter of our holes are 5 mm, so I'll only change the diameter field to 5 and click Select to exit the tool table. In the Levels branch, I'll click on Upper Level and select the top face of our model in the SolidWorks graphics area, then click OK to accept. Next, I'll select Drill Depth and pick the bottom face of our model, then click OK to accept. I am going to select Full Diameter under Depth Type to ensure these holes are drilled to the full depth by the full diameter. In the Technology branch, I'll use the default settings. The sorting will be calculated automatically, and the drill cycle type will be our standard drilling method, G81. Now I'll click Save and Calculate to add this drilling operation to the CAM tree and calculate the toolpath. Again, I'll simulate our toolpath by clicking Simulate. This time, I will highlight all the added operations in the CAM tree by selecting them. This will enable us to play the toolpath for all operations. I'll press the Operation Step Mode button to play the toolpath per each operation. The toolpath looks great. Next, I'll switch to the Solid Verify tab and play the simulation again using the Operation Step Mode button. The tool moving through the solid stock material also looks great. Now, let's exit the simulation and drilling operation dialogues and generate Gcode. From the SolidCAM Manager, I'll right-click Operations, Gcode All, Generate. The generated Gcode for a 3-axis HOS opens in Notepad. It's that easy to cam apart and generate Gcode with SolidCAM. For an even further in-depth look at programming this part with SolidCAM, please go to Getting Started with SolidCAM Professor, a chapter in our interactive guide. Thanks for watching. For more great SolidCAM Professor videos, visit the Professor tab at www.solidcam.com.